Today we will discuss on the topic of detection of Parkinson's disease. If you are feeling unwell due to some reason, you are feeling very tired or your head is paining, or for some reason you just are not functioning as normal, you're not feeling well, you will take some rest and try to relax. But if you still don't feel that way or you still don't feel well, you go to the doctor. Now, the doctor checks you. He looks for symptoms, looks for what, asks you whether you slept well. He asks you a series of questions, and based on that, he gives you an answer. He diagnoses you with a condition, or what he tells you what your problem is. Then he gives you a list of medicines you will require for to deal with that condition. You take the medicines on the times the doctor has told you to and in the dosages, and after a day or two, you are back to normal. This is what happens in the case of a correct diagnosis by the doctor. So, if the doctor has correctly diagnosed your condition, it's going to be smooth. However, there is another way that this could happen. There is another scenario that can play out. There are many different types of health conditions and problems. Some are easier to detect than others. The reason it's difficult to detect some conditions is because many conditions share same symptoms. They will have the same symptoms or signs with other conditions. For example, you have a headache, pain in the abdomen, and you are feeling unwell. These symptoms could point to multiple diseases. It could be malaria, pneumonia, influenza. Because the symptoms of all these diseases are so similar, there are some patients who get misdiagnosed, wrongly diagnosed with a condition they don't have. Misdiagnosis is a very big problem for the health and well-being of the patient. It causes unnecessary pain and suffering. It causes medical complications, unnecessary expense, and a lot of stress to the family and the patient themselves. Roughly 5.2 million people are misdiagnosed every year in India, out of which 30,000 patients expire due to the misdiagnosis. While it is understandable that doctors are not supposed to make such mistakes, since their mistakes can cause serious harm to people's health, doctors are also human beings. They also sometimes make mistakes. The solution is to find a way of verifying or correctly diagnosing a condition in a way where there is less room for error. Let's talk about Parkinson's. Parkinson's can be misdiagnosed as its early symptoms or signs are very similar to many other conditions like essential tremor, Alzheimer's. These are all different health problems which are very similar to Parkinson's. Common symptoms of Parkinson's include shaking, twitches, and tremors in the body, slowed movement. Movements of body become slowed down, simple tasks become difficult and time consuming. As your body takes longer to do things it could do easily before. Changes in walking, the steps become shorter while walking. It becomes difficult to stand up due to unsteadiness. It feels like the person may fall while trying to get up. Dragging of feet while walking. There will be balance problems. Limbs will be very stiff. Manner of speaking will change. The person will speak the whole sentences in one tone without any change in voice, hesitating before speaking, speaking quietly and softly. It is mainly based on these motor symptoms that a neurologist can identify Parkinson's, and through this method he can identify, and this method has a good accuracy, but it takes 2 to 3 years to identify or correctly be sure that it's Parkinson's. So what exactly is Parkinson's? Parkinson's is a disorder, a problem in the central nervous system which connects the brain to all the parts of the body, and this affects movement and your normal functioning of the body. So simply the cells in your central nervous system decline. Around 30% of Parkinson's patients are misdiagnosed. Only neurologists can accurately identify Parkinson's. Any other type of doctor will require expensive tests to be done, and even then, misdiagnosis chances are higher when compared to a neurologist. Also, there are many conditions which would give similar test results as Parkinson. For example, there is drug-induced Parkinson's, Parkinson's plus syndrome, essential tremor, Alzheimer's, etc. The way a neurologist checks for Parkinson's is here, given here. First, he will evaluate the patient's condition, the medical history. Then he will get a blood test and urine sample before administering a drug known as L-DOPA drug. If the L-DOPA drug has an effect, it means that there is a high chance of it being Parkinson's. However, the result of L-DOPA test is not always clear, and because of that, the scans, the MIBG and dopamine transporter imaging, imaging inspection scans and tests have to be taken several times for the neurologist to be certain whether the drug took effect or not, or whether the person is suffering from Parkinson's or not. This whole method has some disadvantages. Sometimes it may take very long for the neurologist to be certain that the condition the patient is suffering from is Parkinson's, and I explained why earlier. And if the diagnosis is too late, then there might be problems for the patient. Secondly, this process is not fast enough. The process requires multiple tests and visits to the doctor, who may change his opinion as time passes. And it is difficult to take a Parkinson's patient to the doctor since they are not in the state to travel. Walking is difficult for them, movement is difficult for them. So, taking them to the doctor back again and again and taking them for tests is a very difficult thing to do. Higher chance of misdiagnosis. Doctors make mistakes all just like humans, as they are also humans, and the tests do not always give a clearly understandable results. So many times the neurologist has to wait for the condition to give a clear sign. This waiting may result in worsening of the patient's health. So how do we prevent these problems? How do we prevent misdiagnosis from happening? Going to a neurologist is not always affordable, it is expensive, requires multiple visits, and there are still some problems in that matter. So one way that can be used is by analyzing the speech or voice of the patient. This can help detect Parkinson's disease at earlier stages than is now possible. Around 75 to 80% patients affected by Parkinson's go through changes in voice. They talk much faster and their voice becomes low and difficult to hear. Also, their voice becomes breathy because Parkinson makes it difficult to breathe properly, especially while speaking. By using speech analysis, which is simply when you study the way a person speaks, you can detect Parkinson's at a much earlier stage because people with Parkinson's speak in a very pronounced, very different manner. To do so, the patient will have to go through a voice test. So they will record some audio of the patient speaking, then they will give it to a audio software which will give them audio statistics like MFCC, time frequency features, vocal fold features, you know, terms that some people may understand, but for us they are just terms. And then by using the values of these variables and verifying them against the result, a person who knows about all of these terms and what they mean, MFCC and time frequency features, etc., that person can notice patterns. And using those patterns, a person who understands all the speech statistics in detail and has studied them, he will be able to predict whether the person has early stage Parkinson's or not. However, in this case, we are once again depending on a person or a group of people whose analysis can be accurate only 70 to maximum 75% of the time. Also, it will require the person a lot of time to understand how each of these many variables is related to the target, whether the person has Parkinson's or not. So instead of using a person, there is another solution. We can use a machine learning model, or we can use simply a computer to go through this data. and the results of whether the person was suffering from Parkinson's or not. And we can let this computer identify the patterns in the data, since computers do not make any mistakes like humans. This process of studying past data, finding patterns, and using them to predict the future is called machine learning. Using machine learning, such tasks can be done quickly, efficiently without any waste of time and space, and accurately with a higher accuracy than humans, because machines make less error. There are many types or methods of machine learning in which the data is studied or analyzed by the model to capture the effect of every feature or every variable over the result. There are also many that can analyze the effect of multiple variables over the result. The most popular are linear regression, logistic regression, decision trees. We will go into detail of these methods in future videos. However, each of these methods has a limited accuracy. And in the case of Parkinson's disease, we require the accuracy to be at least 90 to 95%, because we need a method which is much better than the 70 to 75% we are achieving now. For this, there is a method known as XGBoost, which was created as recently as 2016. So XGBoost is an ensemble learning method. What this means is that instead of using one learning method like logistic regression or linear regression or decision trees, this method will use a learning method multiple times. So what happens is these multiple learning methods predicting powers will be combined. Their accuracy will add up and their errors will decrease. The result is an ensemble learning model. Ensemble simply means, when some ensemble means many coming together. So ensemble learning model, the result will be that will predict the output more accurately by using the prediction accuracy of every method in the ensemble. XGBoost uses boosting, which is a method in which decision trees are built sequentially or one after another to reduce the errors of previous trees. Each tree learns from the one before it and reduces the error, so that the tree which will come next will further improve, and so on until the error is negligible. The learners or models in the ensemble model are called base learners. For example, our model has 4 base learners as is shown here. Base learners are weak learners whose predictive powers are slightly better than random guessing. Here you can see they all have accuracy of less than 70%. The best is like this 4th base learner has 70%, but the others are around 60. Each of these weak learners is good at understanding the relation between one particular variable and the output. So by combining these weak learners, the boosting technique is able to create one strong learner who can bring down the error and increase the accuracy. Decision trees are used to categorize or make predictions based on how a previous set of questions were answered. So for example, here we have house price prediction data, and we want to find the pricing of the house based on area, number of bathrooms. And for example, our 1 BHK size is around 800 square feet, and our 2 BHK size is around 1200 square feet. So then based on the number of rooms, it will search for all records which have an area more than 1000. So this will be all the 2 BHKs, and all the 2 BHKs will clearly have a higher price. You can see all the 1 BHKs have around 60L, while the 2 BHKs start at 70. So it will search for all records which have an area of more than 1000, which will be all the 2 BHKs. And then it will take the average price of all the 2 BHKs, and simply for every time it has to predict a record which has more than 1000 square feet area, it will predict the average for the 2 BHK. Taking this model further, it will, because it's a decision tree, so this is only one node. So there is a root, which is our variable, and from that we have predicted one variable, only area in square feet. But now let's take number of bathrooms into consideration. So if a 2 BHK has one bathroom, its average price is, suppose the average price is 79.6 lakh. So how did we come on this number? So we said, okay, area more than 1000 square feet. If yes, then check for number of bathrooms. If no, then don't, because anyways all the houses with area under 1000 square feet have only one bathroom. So if it is under 1000 square feet, the answer is simple, 61 lakh, which is the average that we computed by adding 62 lakh with 60 lakh and then averaging. If area is more than 1000 square feet, then check if it has more than one bathroom. If it has more than one bathroom, then it will search for all records which have an area of more than 1000 square feet and have more than one bathroom. So there are three over here. There is record number 4 with 1470 square feet, record number 7 with 1500 square feet, and record number 8 with 1400 square feet. So it will average out the prices for these three and it will get the value 79.6 lakh. And what if the area is more than 1000 square feet but number of bathrooms is less than 1, not more than 1? So the answer to more than 1 will be no, and the average for that, it will once again see, okay, where do I find houses with area of 1000 square feet and less and only one bathroom? So it will find record number 3, 5 and 6. It will take their values, which are 71 lakh, 68 lakh, 72 lakh, average them and get the prediction, which will be 70.3 lakh. This is how a decision tree works. Now in this example, we have the data of weather and we want to predict this decision variable, which is the number of golf players on the field that day. So before a person goes to play golf, he will always check the weather. Why? Because it affects the playing conditions. So here we have outlook, temperature, humidity, wind. These are our independent variables or our X, and decision or the number of golf players that day on the field is our dependent variable or our Y. Using the X variables, we want to be able to predict the Y variable. So how will our decision tree be created? So based on the outlook, whether it is sunny or rainy, our decision tree will decide which variable is the best predictor of the golf players. If it is sunny, then the next thing is temperature, because if it is sunny, people just want to know, is it too hot? If it isn't, then more people will come to play. So you can see the day, whenever the outlook is sunny and the temperature is just cool or mild, more people came to play, around 38 to 40. But it was hot, only 28 people came to play at an average. While in case of rain, temperature doesn't matter because anyways it can't be too hot. So what matters when it is raining is whether there is too much wind, because when there is too much wind, playing golf becomes difficult. The ball starts flying here and there, your shots start going wrong. So they check whether there is a weak wind or a strong wind, and clearly the days when there is a weak wind, more people find it favorable to come and play. And by using these variables, the decision tree is here able to predict the number of golf players for every instance. To improve this model, boosting creates several decision trees one after another, so that the error made by the first tree and the 4x variable, so it takes the error and the 4x variable from before, and this is now given to the second decision tree. So here you can see we have got the same data, but our y, our predicted, the variable we wanted to predict is now the error. So we are no longer trying to accurately predict the number of golf players, we are trying to now minimize the error. So now this new data set will now be given to a second decision tree, which will compare the x variables with the error and create another decision tree. And based on that, after the errors or distance between predict and actual golf players will be fed into a third decision tree, and so on until we have decreased the error to where it is very low. So for example, this is the output of the third decision tree. So most of the error is literally wiped out. The maximum error left is 2.8. So we keep doing this until our error is very minimum. This is how boosting works. Here you can see how a boosting model works visually. It combines the learning from each tree to create a better tree. So based on how many points are misclassified in every tree, wrongly classified, it understands which decision tree should be given more control over the output or the combined results. In this example, tree 2 and tree 3 have the higher influence when compared to tree 1, because tree 1 is not correctly classifying any data point which the others are unable to. So you can see in tree 2 correctly classified 2 points, which correctly classified 2 points and misclassified 1 point. The reason tree 3 is, you can clearly see, it is a good predictor. It misclassified only 1 point but correctly classified the other 4 positive points. But the reason we are taking the results of tree 2 as well is because that 1 point, this one red point which tree 3 misclassified, tree 2 correctly classified. So just for that 1 point we are also giving influence to tree 2. But tree 1 did nothing of that sort. There is nothing that trees 2 and 3 correctly failed to classify that tree 1 correctly classified. So that's why it will have low influence. You will notice that the boundaries, or the blue area, which is known as decision boundaries, are different for every tree. This is because every tree uses the variables differently. Some tree may use the area and square feet variable first in our house price data example, while another may use number of bathrooms first. So it may say, okay, number of bathrooms more than 1, and then it will go to the square feet. Depends. XGBoost uses gradient descent to minimize errors by deciding which trees should have more influence over the output. So the way gradient descent works is, so the way this happens is, the influence of the tree over the output is decided is by multiplying the output of every individual tree, so in this case tree 1, tree 2 and tree 3 with a weight. If the weight is higher, the impact of that decision tree on the output will be higher. Initially the weights are randomly selected, and then based on the error the weights are tweaked until the error is at the lowest possible point, also known as global minima or minimum cost. So here you can see your initial weight will be some random value. Then with every step you will decrease your error by increasing your weight. In this case it is decreasing, but suppose it is increasing. So with every step you will increase your weight, or it could be that, for example, this is for tree 1. Now tree 1 does not need such a high influence because it's doing nothing which is correct, and because we are giving it such a high influence we are having higher error. So here we are simply decreasing its influence by decreasing the weight. The smaller the weight will become, the smaller the output the tree 1 will have influence, because if it becomes 0.01, no matter what tree 1 predicts, when multiplied by 0.01, literally nothing will be considered because it will be such a small value. So that is why we are trying to minimize the error, and that is by going either decreasing our weight or increasing, and sees whether the error is increasing or decreasing. If I am increasing my weight and my error is increasing, that means I have already passed the lowest error point. So now I'll have to come back. Another algorithm we will be using, so this is an example of weights. I have multiplied weights into the decision trees here. So another algorithm we will be using is scaling. Scaling converts all values of our x variable into a range between 1 and 0. This makes sure that no variable has more influence on our output variable just because it is bigger. Only the weights or our gradient descent should be allowed to give a variable or decision tree more influence. Just because the number is bigger doesn't mean that variable is more important. Here I have given an overview of how our machine learning model will work. First, we will apply min-max scaler to the data, and I will explain what min-max scaler is. What min-max scaler will do is it will simply convert all values to between 0 and 1. Then we will split the data into a training set and a testing set. The model studies on the training data and then makes predictions on the testing data, and then based on the errors improves itself over time. We will keep our training set 80% and our testing set 20%. After this, we will feed our data into the XGBoost model, which will make the predictions and get an accuracy score of around 95%. Scaling. So standard scaler so there are three main types of scaling: standard scaler, min-max scaler, and robust scaler. Standard scaler uses the mean, which is the average, and the standard deviation. Deviation is by how much the data differs from the mean, and the standard deviation is the average of how much the data can be different from the mean. Min-max scaler takes the highest value and lowest value to scale the variables using the formula x minus minimum divided by maximum minus minimum. Simply, it checks your current value against the maximum value. The maximum value is treated as 1 while the lowest value is treated as 0. The rest of the values fall in between. For example, this is our house price data here. If we are scaling area, then 1500 is the max, 750 is the minimum. So if we min-max scale the highest value, it will return 1500 minus 750 upon 1500 minus 750, which is equal to 750 upon 750, which is 1. So when you try to min-max scale 1500, it is 1, which is the highest possible value. If we take 750, you will get 0, which is the lowest possible value. And if you take any other random value, like the third record, which has 1110, you will get something like, here you have 0.48, so some number between 0 and 1. This prevents any, just because now here what will happen is the machine will say, okay, since area in square feet is such a big number and number of bathrooms is so small, let's give any decision tree which is using area of square feet first higher advantage, which is not necessarily always the case. Here it is the case, but it's not always like that. So by scaling, because all our values are between 0 and 1 now, both variables will be treated equally. Robust scaler uses the values which are placed on the 25th percent and 75th percent. We will go deeper into robust scaler in a future video. This is how our XGBoost model will work. First, it will create multiple decision trees one after the other. It will let each tree generate an output, use gradient descent to find the correct weights or the correct importance for which tree is more important. Once the training is over, the model will make predictions by getting the average of the decision tree results. This will help achieve higher accuracy, that is 95%. Now let's get to the programming part of the project. We will be using Python and a software called Jupyter Notebook. First, we will import necessary libraries. Libraries simply consist of large blocks of code which are given names through which you can call them. Earlier, there were no libraries and you had to manually code everything yourself. For example, if you don't know the name of a person and want to talk about him to a friend, you will have to ask your friend the guy's name. And for that, you will have to make it clear which person you're talking about. And the way you'll have to do that is by giving a list of his features, how he looks, what he wears, where you met him, etc. And then your friend will recognize him and give you the name. When you start using the name, you no longer need to tell the whole description again. You can just use that one word name and your friend will know who you are talking about. Similarly, when using libraries, you don't need to type in the whole code. You can just call the code from the library in one line and use it. For example, area of a circle. Rather than every time taking the radius, multiplying it by pi and then squaring that value, you can just say from numpy import area of circle and then say okay, I want area of circle, radius is 32, and it will give you that. You don't have to code pi r square. Different libraries are used for different use cases. NumPy is for math, right? So that's why I imported the area from it. NumPy is for math. It handles all math operations like mean, median, mode, area, etc. Pandas is for handling and changing your data. If you want to remove a column, add a row, etc., pandas is used. sklearn is a very important library which has a lot of important machine learning functions in it. Train test split I have already explained. It splits the data into two sets. Then we will get our file from the file address and see how many rows and columns we have by using the shape command. And then we will have a look at the head of the data, or the top 5 records of our data. Here we can see that our data consists of vocal statistics or value. I repeat, we do not need to understand what every value is. Our machine learning model will do that for us. And by using these values, which we cannot make sense of, our model will be able to understand and diagnose the speech problems which occur commonly during Parkinson's. Here you can see an example of why I said scaling is necessary. MDVP, our first variable, MDVP-FO in Hertz, has values like 119. While this value, this is I think the fifth value, MDVP jitter ABS or absolute, has values like 0.00007. Now because of this, only these first three variables will have any effect on our output. The others will become close to useless. And because we don't want that to happen, we will convert all of these to values between 0 and 1. The exact relation of each of these variables to Parkinson's will not be shown to us, but the model will know. So next, whenever we take the audio or speech test values to the model, it will immediately apply what equation it has derived or what it has learned, and know if the if MDVP is below 100, then the person suffers from Parkinson's. This is just an example. So by applying this rule based on all the variables, the model will know if the person suffers from Parkinson's or not, and it will be able to correctly do this 95% of the time. Here we will separate our labels from our features. Any mistake in doing this will result into our testing data answers leaking into the training data, which will allow the model to perform better than it actually is. Just like if the answers to an exam paper are accidentally given along with the question paper, the students will perform better than they actually can. Since they have all the answers given to them, they just need to copy them. Here we are scaling our values between -1 and 1. Here there is an option of -1. In our house data, it wasn't there, since a house cannot have negative area. After this, here we are doing train test split. Our test size is 20 and random state is 7. Random state is used so that you can get the same set of random values again. Simply the number 42 in this case can be used to generate the exact same random records that you have, so that everyone working on the same project are using the same data. Now we are calling and training our model on the data, getting our predictions and testing them against the actual answers of the testing set. Then we get the prediction accuracy, which will be around 95%. So in summary, by using machine learning, we have solved all the problems faced with Parkinson's disease detection. Late realization of disease being present is solved by speech analysis, using which we can detect the speech problems that occur with Parkinson's in the early stages. The problem that the process wasn't fast enough is solved by XGBoost, which is a boosting model programmed to increase speed. It is close to 100 times faster than gradient boosting. Higher chance of misdiagnosis is solved by XGBoost again, which has a 95% accuracy. And the problem of test results of L-DOPA and other important tests being difficult to interpret is solved by us taking speech statistics, which our model can easily interpret. So there is no reason for us to retake tests. Overall, there are still improvements which can be made, since a 5% chance of misdiagnosis for Parkinson's when compared to the 60,000 new cases every year in the United States alone means that 3,000 misdiagnoses will happen just in the United States. It is still a big number. We can use robust scaler to increase accuracy, and try deep learning, which may help us achieve better accuracy. We will cover these concepts in the future. Thank you. Bye bye.